Hi everyone, this is Soumyadeep Paul. In the last video, we understood what data structures are. But today, we are hoping to unlock something even more important, which is how to classify them. Because once you understand this, every problem becomes much more easier to approach. So, let's take a quick recap. We saw data structures, and what were they? Data structures were nothing but a to way to store and organize data efficiently. That's all it was. Way to store and organize data efficiently. Okay, yeah, this was what data structures is efficiently. Now here's the thing, not all data structures behave the same way. As we saw that there are plenty of data structures: heaps, queues, priority queues, linked list, stack, queues, etc. And all those data structures don't behave the same way. Broadly, all these data structures fall into two categories. First is the linear data structures, and the second is the non-linear data structures. Okay, linear and non-linear. Now, linear means that the data is arranged in a sequence, one after another. Okay, like in a straight line. So the data is arranged in a sequence, one after another. Think of it like this: students standing in a queue. Each person has one person before and one person after. Okay. And examples of linear data structures will be arrays, linked lists, queues as well, and stacks, etc. Okay. So in all of these, you move from one element to the next in a single path. Imagine something like this: A, then B, C, then D, and so on. There's only one way to traverse, only one direction, only one way to traverse. You cannot jump randomly in most cases. Well, yeah, in arrays you can jump using indexes, but still that is something different. Okay. But in non-linear data structures, the data is not a single sequence. Data is not a single sequence. This is the main difference. Data is not a single sequence. So it comes from a hierarchical or network structures. Either there will be some sort of a hierarchical or network structure. Okay. Okay. Some examples will be graphs, trees. You have generic trees, you have binary trees, you have binary search trees, all sort of trees, heaps, priority queues, etc. Okay. So think of it like this: a family tree. One parent can have multiple children, and each child can have more children, like we have in trees. So the entire structure branches out, isn't it? One node, one data point can connect to multiple more data points. There are multiple paths. So let's make this super clear. With linear, you have just one path of following something. Okay, with linear data structures, you have just one path. But with non-linear, you have multiple paths. Okay, you have multiple paths. And linear is sequential, whereas non-linear is hierarchical or a network structure. Okay. But you might be thinking, why should I care about this? And here's why. The type of data structure you choose depends on the problem you have at hand. If your data is sequential, whatever lead code problem you're doing, suppose you're in an interview and they've asked you some data structure question, and whatever problem you're trying to solve, if the data that is coming or the data that you have to store is sequential, you use a linear data structure. But if your data has relationships, you use non-linear data structure to store them. Okay. So let's take some real world examples. Let's jump into some real world examples. For example, you're storing songs in Spotify. You are a developer at Spotify. Imagine you're working at Spotify. You're one of the top developers in the whole world and you want to store songs. So you'll be storing songs. This is a linear data structure. You'll use some linear data structure to store it. Because a listener, someone who is using the Spotify app, will be listening to songs in a sequential manner, one after another, after another, after another, and so on. Okay. Suppose you're developing a operating system. So the files in your operating system, they are stored in a tree-like data structure. Because if you think one folder will have multiple folders or files, then every folder can again have other folders and files inside it. So it is like a never-ending branching out structure. There can be one folder, folder 1. Inside folder 1 you can have folder 2. This is a file 1. This is a file 2. This is a folder 3. Okay, inside the files are ending points, because inside a file you cannot have anything other than the content. But inside folders you can have file 3, file 4, file 5. Here inside folder 3 you can have folder 4, file 6, folder 5. So inside folder 4 you can again have file 7, folder 6, file 8. Inside folder 6, folder 5 can be empty. Folder 6 can again have file 9. So this is an entire tree-like structure. So files are stored in a tree-like structure. Suppose you are a developer at Meta, Facebook, or some other social media platform like X, Twitter. So social network is stored in a graph-like structure. Okay. So in interviews, many problems becomes very easy if you just identify whether it is a linear or a non-linear data structure. That is literally half the problem solved. Okay. So in the next few videos, we will be starting to deep dive into these data structures. And after one or two sessions, after one or two videos, we'll jump into arrays, which is your very first linear data structure. And then we'll slowly build up from there. Okay. So if you're following the series, make sure you don't skip, because each and every concept builds on the previous one. And in the next video, first we'll cover something really, really important called as time and space complexity. The most important concept for writing good, efficient code. Okay. So I'll see you in the next video. And if you want to learn these concepts in a much more deep dived manner, where you become capable enough to crack any interview of any product-based company all across the world, then do join CodeKerdos.